Welcome, I am Suresh from Civil Department, Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today, in this class, we discuss about photogrammetric survey. Okay, here I'll cover the topics related to types of photogrammetric survey and introduction part. So first of all, what is photogrammetric survey? Okay, so what is photogrammetric survey? We discuss in this class. So photogrammetry is derived from Latin word where photo means light, gra to draw or measure, and metry means measurement. So in presence of light, we'll draw and measure some physical quantities. Okay, that is called photogrammetry. So in presence of light, we're going to draw and measure some physical quantities on Earth's surface. It's called photogrammetry. So here, so photogrammetry is not only the recent advanced survey; it is from very previous years also. It is there. So it is on top of advanced surveying where we discuss about total station, remote sensing, photogrammetric, GIS, and GPS. This all come under your advanced surveying. So here, photogrammetry is a technique where we can obtain the physical quantities of an object by the process of measuring, recording, interpreting, analyzing the recorded data. So here, in fact, photogrammetry we have definition here. So it's the art of science and technology of obtaining information of physical objects or quantities and the environment by photographic and environmental images. Or we also can define the definition as it's art of science in which physical quantities of an object can be obtained by the process of measuring, recording, interpreting, and analyzing the recorded data. So there are few categories are there in photogrammetry shown here. So metrical photogrammetry, it is obtaining in measurements of from photos from which ground position, elevation, distance, areas, and volumes can be computed, and topographic and planimetric maps can be made. And photo interpretation, nothing but evaluating of existing features in an qualitative format. Or we can simply say we can obtain the physical quantities of any object by metric photogrammetry or photo interpretation. So after taking the photograph, we go for interpreting, analyzing, and extracting the data which is being captured. So there are different types of photogrammetry. In fact, we discuss only the two types of photogrammetry. One is aerial photogrammetry and next is terrestrial photogrammetry. Now what is aerial photogrammetry is? Aerial photogrammetry is a method of photogrammetry where photographs are captured using airborne vehicles which are moving at a constant velocity from the ground surface, and these airborne vehicles capture the photographs of required area by overlapping 60 to 70% of previous image. Okay, so they will overlap 60 to 70% of previous image. That is called aerial photogrammetry. So we are having DRDO. So DRDO have launched an airborne vehicle called Rustum 2. Okay, so DRDO has launched an airborne vehicle called Rustum 2 for the purpose of aerial photogrammetry. So a series of photographs of an area of terrain in sequence using precision camera. Or we also can define aerial photogrammetry is a method of photogrammetry where photographs are captured using airborne vehicles by overlapping the previous image by 60 to 70%. Okay, and terrestrial photogrammetry. So if you want to capture an area or a field of land like this, in terrestrial photogrammetry, we use terrestrial heights. It may be a top of a tower or a building. Okay, we keep a photo theodolite here and theodolite here. So from the left side, we capture one image of this photograph, and from the right side of the terrestrial height, these two are of equal heights. Okay, h, and this is also of height h. H is equal to h of same altitude, or if it is 10-meter height, it is also 10-meter heights. Okay, it is all 10-meter heights. And from here right side also we capture the photograph like this. Okay, so by the process of stereoscopy we can obtain the physical quantities of an object present in this photograph which we have captured using terrestrial photogrammetry. So terrestrial photogrammetry is also a method of photogrammetry where we can capture the photographs. Okay, terrestrial photogrammetry is also a method of photogrammetry where we can capture the photograph using terrestrial heights. So here we use phototheodolite, whereas in aerial photogrammetry we use camera fixed on airborne vehicles like Rustum 2. So in terrestrial photogrammetry, we will capture the photographs from terrestrial heights. It may be a top of a tower, or it may be a top of a hill, or it may be a top of a building. Okay, it may be any one of these features. So here the height should be equal. So it is some height is some 20 feet. Here also the height should be from 20 feet if you are capturing the image between these two terrestrial heights, right? So close range photogrammetry, camera close to object being observed, most often used when direct measurement is impractical. So when direct measurement is not practical, we go for the close range photogrammetry. So in fact, we have to discuss about the terrestrial photogrammetry and aerial photogrammetry in this course. So photogrammetry for engineering. So what is photogrammetry? We are clear. So it's a process of measuring images on photograph. So before going to photogrammetry, we discuss types of photographs. So we have vertical photographs and we have oblique photograph. So we have vertical and oblique photographs. So vertical photograph and oblique photograph. Again in oblique photograph we have two types. One is low oblique and one is high oblique. Whereas in vertical photograph we have again two types. Vertical or tilted. Okay, we have vertical or tilted, and again oblique, low oblique and high oblique photographs are there. So irrespective of the method, it may be a terrestrial photogrammetry, or it may be what we call terrestrial photogrammetry, or it may be aerial photogrammetry, but the photograph may be tilted or it may be vertical. Okay, so photogrammetry is a process of measuring images on photograph. The images are of the ground. Okay, I'll show you some related images to this photogrammetry. So modern photogrammetry also use radar imaging, radiant electromagnetic energy detection and X-ray imaging called remote sensing. So if you observe carefully, here photogrammetry remote sensing, GIS, okay, and you can take GPS or EDM. These all come under your higher surveying. Okay, so here is photogrammetry, remote sensing, and GIS are relevant. So these three are relevant and they work together. Suppose if I want the data, I mean we can apply these application various phenomena. That is why sometimes the photographs we apply in remote sensing to sense the information of particular soil type, capacity reservoir or climatic condition like that. So the photograph what we have captured from terrestrial or aerial photogrammetry that can be applied broadly in various applications. So these remote sensing, photogrammetry and GIS are always combined together. In remote sensing we can sense the data. So in remote sensing and photogrammetry, we can capture the photograph in visible spectrum only. Okay, in visible spectrum only. But in modern photogrammetry, we're also capturing the images in radar imaging, in radiant electromagnetic energy or X-ray imaging. So electromagnetic energy detection and X-ray imaging detection. So as we know, in electromagnetic spectrum, we have various X-rays are there. So starting from microwaves, UV, IR, near IR, far IR, X-ray, gamma ray, like that, we have various rays are there in your electromagnetic spectrum. So based upon the energy and the X-ray imaging, this photogrammetry is also called as remote sensing in few cases. Okay, photogrammetry, modern photogrammetry uses radar imaging, radiant electromagnetic energy, and X-ray imaging energies. So they are calling as remote sensing. But the application is for all. We can apply this technique in various things. So I said that this photogrammetry is not only the recent technique, it is from World War II. In this picture, you can observe a pilot. It is an human vehicle. Actually, DRDO has launched Rustam 2. That is unmanned aerial vehicle. We call UAV, but it is human aerial vehicle HAV. Okay, so unmanned aerial vehicle launched by DRDO called Rustam 2. Whereas it is human vehicle, it is an oldest version of vehicle. So he is capturing the images related to World War One. So World War One was the major impetus to develop the aerial photogrammetry. So after the World War One, you can see two pilots are there. One is capturing the photograph and one is driving the aircraft. So now after the World War One, World War Two, after 1970s, in 1960s, 1970s, there is a broad change in photogrammetric techniques. Okay, so with the help of DRDO, we have taken various photogrammetric images. So here I can say you types of photograph. Just now I say you we have different types of photographs. So this is called vertical photograph. This is called low oblique photograph. This is called high oblique photograph. High oblique photograph. So based upon the camera axis, okay, we are classifying the photographs into three types. First of all, two types: vertical and oblique. Again, in oblique, we are having oblique. Again, in oblique, we are having two types: low oblique and high oblique, based upon the camera position. So, if I want to say this photograph is exactly vertical, okay, when a camera axis is exactly parallel to the plumb line, okay, if my camera axis do not tilt more than 3 degree, if the camera axis is not tilted more than 3 degree, then such photographs are called vertical photographs. If camera axis do not tilt more than 3 degrees, it may be tilt. Why? Because when aircraft is flying in atmosphere, we have various factors which govern the position of aircraft. Okay, this is vertical photograph, which govern the position of aircraft, like dragging force, gravitational force, okay, thunderstorms, wind pressure, various atmospheric pressure, various forces acting on the aircraft. So sometimes it is very difficult to take the photograph from exact position or exposure station. Okay, so here in vertical photograph, if the camera axis do not tilt more than 3 degree, that photograph is called as vertical photograph. Okay, so if camera axis is tilted more than 3 degree, we call oblique photograph. Okay, if camera axis tilted more than 3 degree, we call oblique photograph. If camera axis not tilted more than 3 degree, it's called vertical photographs. In vertical photograph, you can observe carefully here. You can see only the top view. You can observe the top view. Whereas in low oblique photograph, you can see a view, like we can see some plants here, lake again you can see lake. This is low oblique photograph. And in high oblique photograph, observe carefully. Here the image represent the sky and the earth are connecting. Okay, so here we can observe carefully the earth and the sky are also observed in the photograph. So here the camera angle is very low, so the photograph is very high. Such in case of high oblique photograph, the measurement may be difficult. Okay, we cannot trace the height of the object approximately. Okay, this is the difference between high oblique, low oblique, and your vertical photographs. I'll show you some more figures here. Yeah. So this photograph is an example of your vertical photograph. In vertical photograph, this photograph is captured by using airborne vehicles, aerial photogrammetry technique, or method of aerial photogrammetry. Here you can observe only the top view of the location. If you can see only rectangular box, okay, it may be a shed, or it may be building, or it may be what tower, or whatever it may be. Okay, here also you can see some rectangle pyramid structure like this. Okay, diagonal. You can see some pyramid here. We can see one more rectangle box here. In top view, image can be seen in your vertical photogrammetry. By the process of stereoscopy and other applications, we can extract the required measurement from the image, right? This is an low oblique photograph. Here in low oblique photograph, you can find the 3D measurement. See, observe this building here. Okay, you can see the length, width, and you can observe some height also. Yes, if you take any building here, length, some width and height you can observe here. Height, width, and length. Okay. So we can get the 3D measurement in case of your low oblique photogrammetry. Okay, here the angle is tilted more than 3 degrees. As we know that, we are saying that if a vertical camera axis tilted more than 3 degrees, it represents a low oblique photogrammetry. This is an high oblique photogrammetry. If you observe these figure and this figure, there is a difference here. So in this figure, camera axis is very low and you got a low oblique photogrammetry. Whereas in this figure, camera axis is more than 3 degree. Okay, it is high oblique photogrammetry. And very precise measurements are here. Compared to this image, you can get very precise measurement. If you take this block, you can see the width, you can see the length, you can see the height. And here you can see only a particular section of the photograph. Whereas in this, you can see a group of sections. Here only you can see a particular section, right? Here you can see a particular section, and we can measure the physical quantities, nothing but length, width, depth, or height in photogrammetry. So here we are calling it low oblique, high oblique photograph because the sky and the earth we can see in this picture. Compared to this, sky is absent. Here also only we can see the top view. Side view is there, but greater community. But here only one section where we have a very high oblique photogrammetry. So I define the photogrammetric survey is a branch of surveying in which maps are prepared from photographs taken from ground or air station. If photographs are taken from ground, we are calling as terrestrial photographs. If photographs are taken from air station or using aircraft, we are calling as aerial photographs. With the advancement of photogrammetric techniques, photographs are also being used for the interpretation of geological classification of soil and crops, etc. So if you observe this figure, let us take this figure. No, this figure. So here you can observe the figure for geological classification of crops or soil, etc. So from this figure, you can plot. There is a. You can see this. Yeah. You can see there is a road here in this figure. Okay. You can see some direction. You can see some houses are there. Okay. There is one dead cul-de-sac is there. One dead end is there. Okay. Different types of features can be observed using the photogrammetric techniques. Okay, there are various applications. Okay, so using after the interpretation, the measuring, recording, interpretation, next analyzing, used for interpretation of geological classification of soil and crops, etc. So if suppose we can see greenery, it means that the green crop. We can see brown, it's a dry land. There is no crops. So like that, based upon the color, texture, font, size, shape from the photograph, after interpretation, we can apply this photograph for various purposes. It's a science of making measurement from photographs, especially for recovering the exact position of surface points. So if you want to find the surface points, suppose previously there was a building or a tower on surface. Okay, So this is a 20 years back figure. So recently this building have been collapsed due to a bomb blast or something. Okay, it have been collapsed. But there are some marks. We want to trace these 4 points. Okay, I want to trace the exact position of on the surface points. So recover the exact surface points. So earlier there was a building 20 years back. I will trace the length, width, or the positions of the particular building which have been collapsed. Recently in the Noida, we have twin towers. Recently in Noida, we have collapsed the twin towers because of some illegal construction. After it takes some 3 months to remove all the waste what have been collapsed from the twin towers. Now, I will trace the point. Suppose there are some 24 columns in the twin tower. I want to trace the 10th column position. So that can be done. I can take out the 10th column position using the photogrammetric techniques. Exact position of surface point of 10th column I can trace using the photogrammetric technique also. So there is a very broad application of photogrammetry in recent scenario. Used to recover the motion path of design reference point located on any moving object on the components and the immediately adjacent environment. In photogrammetry, suppose we can trace the moving object reference point located on any moving object. So we can trace the moving object also. Is one of the application. Photogrammetry may employ high speed imaging and remote sensing in order to detect, measuring and record 2D, 3D motion fields. So these are the applications of your photogrammetry. So there are very broad applications which can be used. Just an example of aerial photogrammetry. So this is how a photograph has been captured using aerial photogrammetry. If you observe this figure, this one, this is a camera fixed in an aircraft. Onboard RC camera inside the aircraft. Nothing but this camera will be at the bottom of the aircraft here. Okay, this camera has been fixed at the bottom of the aircraft. So analog photograph by RC camera. So this is a photograph captured by this camera using the aircraft. Okay, this is an analog photograph by RC camera. So it is a vertical photograph or oblique photograph? Yes, it's a vertical photograph or oblique photograph. I'll say it's a vertical photograph only, because I can see only the top views. I can see some rectangular, pyramid or blocks, triangular structures in this photograph. Hence it is in vertical photograph. If it's a high oblique photograph, I can see only the very precise structure with atmosphere. Okay, nothing but will zoom in. I mean, the camera axis is more than 3 degree in case of your oblique photographs. Okay, so we are having plumb line and camera axis. So if the angle between plumb line and camera axis is more 30 degree, it's called low oblique photograph. If the axis between plumb line and camera axis is 40 degree, it is called high oblique photograph. Okay, please remember this. Now, first of all, from this figure, what we want to discuss here. Okay, we are saying it is in vertical photograph. We are saying it is a vertical photograph. So it's aerial photogrammetry where where the photographs are captured by overlapping 60 to 70% of previous image. If you take this image, if you take image here, I'll show you here. So this is first image. Okay, so it can take like this. It's the first image. Photogrammetry is a technique, is a method of survey where aerial photogrammetry is a method of survey where we can capture the photographs by overlapping the 60 to 70% of previous image. So it's a first image one. I'm overlapping this image by 60 to 70%. I'll capture second image. And on the second image again I will overlap 60 to 70%. I'll capture the third image. So this is called aerial photogrammetry. Okay, simple. I'll explain one second like this. Suppose this is my photograph. I have taken the first photograph, photo 1. I have some marks. These are marks are there at the corners of the photographs. These are called judicial marks. Okay, these are called judicial marks, or these marks are taken as spatial reference point. So here I've taken a first photograph from the station here, and I'll overlap this photograph by 60 to 70% again. Okay, I will overlap the same previous image by 60 to 70%, and I'll capture a new image. So again in the new image, again I get the fiducial points like this. For this again I'll capture the 60 to 70% of the previous image. I'll get a new image. By the process of stereoscopy and stereo parallax, I'll measure the three-dimensional view of the photograph which have been captured. So if you observe here, we can see some green color. It's a wetland. We can say there is an agriculture present here, wetland here. We can see some dark brown color. It is a dry land, so it is not suitable for agriculture. We can see some blue color here. It means there is a small lake or water body. So like that, these photographs have been captured, and these can be used for various applications. You can see here also. So we have captured one image in this. So this is one image. So here we have captured a series of images. Suppose you imagine this is area of some Hyderabad or some place. Okay, let me see in Hyderabad. In Hyderabad, this is some village. It may be Dundigal village, something. Okay. You take example. You take a village or any state or any place on earth. In aerial photogrammetry, at first point called exposure station 1, I have captured an image. Okay. Again, exposure station 2, I have captured one more image by overlapping the previous image. Okay. You can so here at first exposure station, I have captured some photograph here on the ground. I am overlapping these photograph for second exposure station, and I have third exposure station. Again, I will overlap the same previous photograph. So first photograph, it is in overlap by second photograph, like this. Okay, and second photograph again it is overlapped by third photograph by 67% of previous image. So for a single photograph, I have taken 3 photographs like this. Okay, when I go for this process of interpretation, analyzing using stereoscopy, I get the 3D view of the particular location, right? So like this, how photogrammetry have been done using airborne vehicles. So here, the point where photograph is captured from atmosphere is called exposure station. Is called exposure station. So in this area, we are having 6 exposure stations. So 1, 2, 3, 4, 5, 6. So if this is the line connects the exposure station, it's called flying line. So if this is a flying line and the flight will take a U-turn, it will go for 6, 7, 6, 5, 4 like this. Okay. So this here we get the side overlap. Here also we get the side overlap. But between 1 to 4, 2 to 5 and 3 to 6, we can get an end overlap. In end overlap, we will overlap from 25 to 30% of the image. In side overlap, we overlap from 60 to 70% of the previous image. Okay. Please remember these percentage of overlapping. So, photogrammetry is a practice of determining the geometric properties of an object from photographs. Geometric properties. So, if you want to measure, what we call, suppose there is a water tank here. Okay, the water tank somewhere on the ground. I want to find the height of the water tank using photogrammetry. This geometrical measure. I can find the length, width, and height of this particular water tank. So we can measure any structure. We can measure contour. We can measure the hills, points, whatever it is, building height, tower, lake, depth of the lake, whatever it can be. We can measure using the photogrammetry. So this is why according to the geometrical properties of an object can be measured. It is a making of precise measurement from photographs. The making of maps from photographs, especially from aerial photograph. So from these photogrammetry, we can make maps from the photographs. The science of using aerial photogrammetry and other remote sensing imaging to obtain measurement of natural and man-made features on the earth. So it is a science of art, whatever it is, of engineering or science of art, in which physical quantities of an object can be measured using aerial photogrammetry. So here we can measure natural as well as man-made features. Using photogrammetric techniques, I can measure the height of Red Fort, I can measure the height of Eiffel Tower, okay, whatever it may be, I can measure using the photogrammetric, man-made or natural structure. I can measure height of some mountain or hill or Mount Everest using the photogrammetric technique. In this method, objects are measured without being touched. So we go for stereoscopy. This is a method of stereoscopy. There we can obtain the 3D view of the photograph what you have captured. In vertical photograph, I have taken a photograph like this. In vertical photogrammetry, I got only some rectangular box like this. I got a two circles here, one triangle here. By applying the process of stereoscopy, I can find the height of these three buildings, height of this oil tank, and height of this pyramid also. Okay. So in vertical photogrammetry, we can measure all the physical quantities of these objects directly. Next, process of making survey and maps using photographs. The science of deducting the physical dimensions of objects from measurements on images, usually photographs of the object. So the making of map by photographs from the air using reference point of known level and position which can be identified on the photographs. So these all are the basic how we capture the photograph and application of the photographs. A series of techniques of measuring positions and altitude from aerial photographs or images. Okay. Next, field application of photogrammetry. So this photogrammetry can be used in various fields. So used to conduct topographic survey or engineer survey. So if you want to study the topography, nothing but study of earth, study of hills, lake, river, plain, plateau, valleys, whatever it is. If you want to study of all these topographical features on earth, you can go for the photogrammetry also. And engineering survey. Like if you want to study the width of dam or reservoir capacity or Statue of Unity height, whatever it is. If you want to find the physical quantities of any man-made or natural or environment structures or features, it can be used by the photogrammetry. Suitable for mountainous and hilly terrain with little vegetation. So on hilly terrain and mountainous terrain where we have slopes, there we cannot go and capture the photograph. So using this technique of aerial photogrammetry, we can capture the photographs. Used for geological mapping, which includes identification of rocks and minerals and rock type and rock structure. So if you visit Survey of India at Uppal, okay, if you can collect the geological map of Telangana or of AP or of India. So these geological map have been made by using the photogrammetry only. So these photogrammetry, they have captured the photograph of Telangana. And these photographs have been applied interpreted using the geological features. So if you take a map of Telangana or India, whatever it is, you take a map of Telangana, something like this. If it indicate dark brown or light pink or grey or blue, visible spectrum, the lights which are in the visible spectrum, okay. So it indicates some colors, some shaded colors like this, or we can see some borders like this, Adilabad, Nizamabad, some borders like this. So whatever the color indicating the soil type will give you the geological mapping or geological features of particular state. Okay. Suppose if you take coastal area AP, if you take Telangana and AP like this, in coastal area we can find most of the green color because there is high vegetation compared to Telangana, right? So like that we can see soil classification, alluvial soil, whatever soil it is. So these colors can be seen only in the visible spectrum only. Okay, used for projects demanding higher accuracy since it provides accurate measurements. So it can be used for project demanding also. Okay, used in urban and regional planning application. So if I capture, so used for urban and regional planning applications also. So used in planning, designing in transport planning, bridge, pipeline, hydro power, urban planning, security and strategic planning, disaster management, natural resources management, city models, conservation of archaeological sites, etc. So these photogrammetry can be used broadly in various applications by various software techniques. Okay, we can use a software and we can use this photograph, whatever we have captured using photogrammetry, in various field of applications. Its application includes satellite tracking of the relative position, alteration in the Earth environment, like tectonic movements also. Okay, the quantitative results of photogrammetry are used to guide and match the results of computational models of the natural system. Okay, thus helping to individuate or confirm new theories and design novel vehicle or new methods for predicting or controlling constitutives like earthquake, tsunami, and any weather types. So the qualitative results of photogrammetry are used to guide to confirm new theories or design novel vehicles to control the consequences like earthquakes, tsunamis, and other weather change in climatic conditions. Suppose in photogrammetry, capture an image, so we can see some earthquake occurred at some Pune. So what you can, based upon the intensity of earthquake, we can plot what is the damage occurred. Okay, frequently for earthquakes occurring in particular zone, we can vacate this zone. Okay, like that we can give some suggestions using the technique of your photogrammetry. Photogrammetry also helps for the solving of triangulation, trilation, and multidisciplinary scalings. In the simple example, the distance between 2 points that lie on a plane parallel to photographic image plane can be determined by measuring the distance on the image. So I like explain like this. In the simplest example, the distance between 2 points that lie on the plane parallel to photographic image plane can be determined. Suppose this is a tower. It may be any cell phone tower, anything. I have a tower like this. We have four now. Yeah, I have tower like this. I want to find distance from A to B, B to C, and C to D on ground. So I have captured the image of the tower. I'll measure AB distance on the photograph which reflects on the ground. Suppose if I use a scale of 1 centimeter is equal to some 1 kilometer or half kilometer. Okay, or a pyramid. You can take imagine a pyramid. This is a pyramid like this. Okay, so I have measured the width of the pyramid or distance between 2 points that lie on the plane to the photographic image plane. I have measured width of the pyramid. That is some half centimeter, 0.5 centimeter, and half kilometer to the ground. If 1 centimeter is equal to 1 kilometer, then half centimeter is equal to half kilometer. Right? It is half kilometer. It is also 1 centimeter. It is half centimeter. It is also 1 centimeter. Like that, we can measure the position, or we can determine the measuring the distance between the image. The scale of the image is known. So you should know the scale of the image. It is 1 centimeter, 1 kilometer, or half kilometer, or 10 centimeter, whatever it is. So if the scale is known, with the help of the photogrammetry, we can measure the distance between those two objects on the photo imaging plane. Important application of photogrammetry. So it is used in various fields. Just now we discussed like topography, geology, architecture, engineering, manufacturing, quality control, police investigation, and geology, as well as by the archaeologists to study the quickly produce plans for larger commercial sites by the meteorologists also. So we are having very broad application. But if you go for advantages and disadvantages of photogrammetry, we also have some drawbacks, merits and demerits. Advantages are it covers a large area. So if you go for the traditional method like chain, tape, theodolite, remote total station, it can work for large area, but it is only 2D. In photogrammetry, just using aircraft or potential heights, we capture the image in short time. So less time consuming and fast. So covers large area, less time consuming, can reach inaccessible and restricted areas also. Suppose the level of crossing is there, LOC. Using the photogrammetry, you can take the image of LOC also, level of crossing, which is not allowed by physical appearance. Such photographs can be captured using the photogrammetry techniques. Cheap, cost effective for large area and in long run. Easy to interpret and understand. So just know whatever I explained, if you understand, it is also easy to interpret and understand. Okay. Disadvantages. So there are some disadvantages of photogrammetry also. Complex system, highly trained human resource needed. So if I cannot send you directly to go and capture image from aircraft. I cannot send you directly go and capture the image from traditional heights. I need to train a human resource to work for this. It's a complex system. I should train the photograph cameraman. I should train the software worker. I should train the measuring, recording, and analyzing the team also. Which one is disadvantage? Costly at the time of installation and initiation. So it is not so cheap. It is very costly. So we require very high sophisticated equipments. We have sometimes we use 12 keys of mouse. So in general, for your mouse, we have only right click and left click like that. For photogrammetric mouses, we have 9 to 12 keys are there. Clicks to give the clicks. We have 9 to 12 keys. So lengthy administrative procedure for getting permission to fly. So if suppose there is a border, it is India, this is Pakistan. It is a highly administrative procedure for getting permission to fly. If I cannot send an aircraft to capture the image at this particular level of crossing between Pak and India or Pak and Nepal or some else, India and Sri Lanka or any neighbor countries. So we require very high permission, okay, for permission to fly. We cannot capture data as per our wish. Okay, there are some restrictions. It takes very lengthy time, sophisticated procedure to get the permission to fly, and it is weather dependent. So weather also should be favorable if you want to capture the photograph. So this is for today's class. So far we discussed the types of photogrammetry, types of photographs, advantages, disadvantages, and applications of the photogrammetry. And tomorrow in next session we discuss the principle of photogrammetry. This will be our next presentation for your tomorrow's class. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.